In this video, we'll be taking a look at how I built a multi-tenant food ordering web app in Laravel. I scaled this web app to over 1500 tenants. We get over 1 million of unique monthly visitors, and this web app processes around 10 million euros worth of food orders every single month. So let's dive in. Multi-tenant applications come in many shapes and forms, and one of the first decisions you'll have to make is whether you want to have a multi-database approach or a single shared database approach. For our multi-tenant food ordering app, we went with a shared database approach for speed and ease of development. However, it's far from perfect, because if our database server is down, it'll impact every single merchant. On top of that, the single database approach means you're constantly doing mental gymnastics in your code when you're doing queries to make sure you're not accessing data of other tenants. I didn't use any third-party multi-tenant packages, as there simply weren't any available at the time I started the project in 2014. In our single database setup, every table has to be linked to a specific tenant, or merchant in our case. So let's, for example, take a look at our orders table. We have an ID, which identifies the order, we have a type, we have a consumption time, and we have some customer information like the customer first name and the customer email. To be able to link this specific order to the right merchant, we introduced a merchant ID column. In our merchant model, we can then create a relationship and access the order on a merchant as follows. Some of our merchants have multiple businesses, for example, a franchise, so we also introduced a team ID so we can easily link multiple merchants to a team. Here are a couple of lessons learned the hard way when working with this tenant identifier column. Lesson number 1 is don't use distant relationships. Merchants love to look at reports, for example, which product was sold the most for the past 7 days compared to the 7 days before. And our schema looked a little something like this. We had a teams table, we had a merchants table, we had an orders table, and we had an order products table. Merchants were linked to the team through the team ID. Orders were linked to the merchant and to the team through the merchant ID and through the team ID, and our order products were linked to the order through the order ID. In an effort not to repeat myself, I didn't include the merchant identifier nor the team identifier on the order products table, because I figured I could access the order products on the merchant through the orders using a has-many-through relationship. The way a has-many-through relationship works is that we have our merchant model that has many orders, and orders has many order products, and we can access the order products through the orders on the merchant using a has-many-through relationship. If you take a look at the merchant model, we can see that we have a direct relation on the orders using a has-many relationship, and order products is a so-called distant relationship which allows us to access the order product through the order. And while distant relationships work beautifully, it has a massive impact on query performance because the complexity of the query drastically increases. Instead, we refactored all our distant relationships and added a tenant identifier on literally every single table. So in this case, by adding a merchant ID and a team ID, we are able to access order products on the merchant and even on the team using a has-many relationship, thus reducing query complexity. This merchant and team identifier is applied to every single table we have in our database schema, because we learned the hard way that when doing reporting queries, it's best to jump through as few hoops as possible. Lesson number 2 is to be extremely careful with orWhere queries. In this type of single database multi-tenant setup, the orWhere query should be used with caution, because if you don't scope your queries correctly, you'll leak orders from other merchants. Let's take a look at an example. In the example shown on screen, we're counting the orders of the merchant with ID 1, where the type equals takeout, or where the status equals completed. If you take a look at the raw query, we'll see that we'll select the orders where the merchant ID equals, in our case, 1, and the merchant ID is not null, and the order type equals, in our case, takeout, or the status equals completed. Now, because of the way MySQL interprets this query, it will find the orders where the merchant ID equals 1 and the order type equals takeout, or it will take every single order where the status equals completed, also the ones of the other merchants. So it's super important to scope the query correctly using the where method on the orders relationship. Using this where method, we're essentially adding parentheses in the raw MySQL query. And if we take a look at the resulting raw MySQL query, we'll see that the order type in our case should be takeout or the status should be completed, but we removed the OR statement and we added these parentheses. And this way, MySQL is able to scope the query correctly. Lesson number 3 is to pay extra attention to the indices. Our orders table quickly grew to tens of millions of rows, and obviously our merchants expect snappy performance on those peak moments when they're preparing dozens of orders per hour. To be able to guarantee this, it's important to profile every single query that gets executed and add the necessary indices before you even start thinking about caching a single thing. A thing we always did was add a foreign index to the merchant ID and the team's ID column, but often we added composite indices to really squeeze all the performance we can out of a query. To figure out which index MySQL uses for a query, you can add the word explain before it, and in the result MySQL will tell you which index it used to execute your query and how many rows it had to look through. Unique indices, for example a slug, also have to be scoped to the tenant, otherwise you'd get unique constraint errors when the same value already occurs with the other tenants. And lesson number 4 is don't use global scopes. Global scopes initially sound like an amazing idea. You can apply a scope to all queries without repeating yourself. However, I found myself removing the global scopes more often than not using the query without global scope method. For example, for our internal reporting, we decided to never use global scopes for tenant-specific queries, and we only used global scopes for global query constraints, like, for example, only querying the orders of the last 5 years. Orders that are older than that are considered archived, and we mark those orders with an archived at date, kinda like soft deletes, and apply a global scope on it. For all other purposes, we opted for local scopes and applied them manually where needed. Now that we talked about the database setup, let's dive into another big aspect of a multi-tenant application, and that is tenant resolving. We provide a webshop for every tenant that can be visited using a dedicated subdomain or a custom domain. We provide every tenant with a free subdomain out of the box. And using middleware, we are able to figure out the tenant when someone visits the subdomain. So let's take a look at our merchants by domain middleware. We have a domains table in our database that maps a domain or a subdomain to a merchant. Our merchant by domain middleware is able to figure out which domain or subdomain is linked to which merchant, and then injects the resolved merchant into the service container. If the merchant is suspended, for example when they don't pay their invoice, we throw an exception and render a specific view for it. And when no merchant is found, we throw a merchant not found exception, which essentially renders a 4 of 4. When merchants prefer to have a custom domain, we have a reverse proxy setup that will handle SSL certificates and proxying to our system with minimal effort. We use a tool called Serix, which makes managing these custom domains a breeze, but more on that in a future video. We also have an API that's accessible through a tenant-specific API key, and in a similar fashion, we apply a merchant by API key middleware that's able to resolve a merchant from an API key instead of a domain. We use this API key in many of our services, for example, our iPad point of sales app. It's important to pay attention to jobs dispatched onto a queue from within a tenant context because they are not tenant aware by default. To provide the job with the necessary context, we always pass in the current merchant as an argument, so we're able to access the merchant model inside of the job handler. And that concludes the video. If you found this content helpful or insightful, give it a thumbs up and consider subscribing. I may do a second part because there's just so much more to talk about. I created an entire video about how a flash sale on a single tenant took down our entire system. So if you're interested to learn more about that specific issue, I'll link it in the description. Thank you for watching, and I will see you in the next one.